Make sure my hair is okay.
Wearing my beautiful shirt.
Yeah, I think we're good. All right, let's do this.
All right.
Go ahead, sir. Take it away.
All right, we're going to work on solving trig equations. Let's take a step back to non-trig equations. You've got a variable, isolate it. In this case, I'll add root 2 to each side. X is being multiplied by 2. I do the opposite, I divide by 2. So x is root 2 over 2. Easy. But what if we replace that x with the trig function? Well, I want to isolate the trig function. My ultimate goal is to solve for theta. And we're instructed to find it one rotation around the unit circle, 0 to 2 pi. Again, divide each side by 2. So I've got sine theta equals root 2 over 2. At this point, I have to ask myself, where...
And yourself said, huh?
That's right. Because to talk to my equal, I have to talk to myself.
Exactly.
That's a reflexive property of psychology. I need to ask myself what angle has a sine of root 2 over 2. If you look on the unit circle, you've got it at pi over 4 and 3 pi over 4. See how off that is?
Yeah. We can do something about it later.
So there we go. That's how we solve these things.
All right, so at this point, what we would suggest you guys doing is pausing the video and trying to solve these by yourself and see how far you get. And then unpause it, hit the play button, and then go through and solve it. So what I thought I would do right quick is go ahead and move forward and show you how all of these would solve.
So pause it now while we play the worst video game ever made.
Yes, the worst one.
The worstest one.
The worstest.
This was a first-person shooter from 1975.
Amen. All right, guys. So let's solve tan of theta equals 1. Again, you want to ask yourself what angle that we take the tangent of to get 1. So remember, tan is y over x, if you remember. So I need some y divided by some x. They have to be exactly the same number or this won't work to get 1. So if you remember, on the unit circle, that's going to be the square root of 2 over 2 divided by the square root of 2 over 2. So theta in this case would be pi over 4. But if we divide a negative by a negative, we also get a positive. So there's another place this occurs in the third quadrant, and that's going to be 5 pi over 4. So those would be the answers for this tangent of theta equals 1. So we come over here to secant of theta, where secant of theta a half. Now if you remember when we were doing these before, we say we write the reciprocal cousin. You quit writing.
Yeah, it's running out of ink.
New messages are available. Okay, and we take and we reciprocate the answer. Now, I don't know about you, but I don't think there's anywhere on the unit circle where the cosine is 2. 1 is the greatest value of cosine, negative 1 is the smallest value. So in this one, there is no solution, and I'm abbreviating solutions. Here, where's the cosecant of theta equal to 2? Same process, we take the reciprocal cousin of cosecant, which is sine of theta, and we ask ourselves where sine of theta is flipped 2 over 1 to 1 over 2, where sine of theta a half. And of course, sine is y, and y is a half is pi over 6. And 5 pi over 6. So there would be the answers there. So I'll come over here. Now this is going to involve a little bit more work. It's not just straight off asking yourself what you need to do. So again, we're going to go through the process of solving for theta, or isolating theta. So we add 1 to both sides, and that's 2 sine squared theta equals 1. That's a terrible theta. Anyway, divide by 2. Sine squared theta equals a half. So of course, to undo the square on sine squared theta, we've got to take the square root of both sides. So when we do that, then the sine of theta equals plus or minus the square root of a half. So plus or minus the square root of a half is a fourth, right, Mr. Simmons?
No.
No, it's not a fourth. So what we want to use here is the quotient property of radicals, which basically means I can take the square root of the numerator and I can take the square root of the denominator. So then sine of theta equals plus or minus the square root of 1 is 1, and the square root of 2 is just the square root of 2. But I don't think we can leave radicals in the denominator.
Yeah, I don't recognize that number as being anywhere on the unit circle.
No, but if we rationalize,
okay.
so we multiply by the square root of 2 over the square root of 2, we get plus or minus the square root of 2 over 2. And plus or minus root 2 over 2 is on the unit
Yes,
circle.
it is. I do recognize that.
Sine again is y. So where's y? The square root of 2 over 2. But it's positive and negative because we took the square root, and there's two values. When you take the square root, there's a principal or positive root, and there's the negative root. So then theta is, oh my God, it's the Walking Dead.
They're coming.
I'm sorry. You know, October the 11th, they're starting. All right, so
9 o'clock AMC.
pi over 4. And obviously they're at 3 pi over 4. And then we hit the negatives.
In the third and fourth quadrant.
That's right, which is 5 pi over 4 and 7 pi over 4. So if you'll look, guys, there's 4 answers because it's plus or minus, positive and negative answers for that. All right, so that's how those are worked out. So let's move on. We've got to solve this quadratic without using quadratic formula. Would you like to do that, Mr. Simmons?
Sure.
All right, take over.
All right. So to solve it without using the quadratic formula, now I'm going to add a stipulation to the directions. Or graphing. Because you could graph the left-hand side on your calculator, the right-hand side, and see where they intersect. We're not going to do that.
Not going to do that.
So if we're not going to solve using the quadratic formula or by graphing, we've got to do it by factoring.
Or guess, check, and revise.
Or completing the square.
Or completing the square. Don't do any of this stuff. Dadgummit, we're factoring. Okay? That's what we're going to do. We're going to factor. Care if you like it.
All right, so I've got 2x squared plus 3x plus 1 equals 0. So it's a quadratic. I've got a square term, a linear term, a constant term. So I know it's going to factor to 2 binomials. Now my 2 is prime. In fact, 2 is the only even prime number.
Yes,
So it has to factor to 2x and x. That's the only way it'll factor. And 1 is also prime. It can only factor to 1 and 1. All right, now I have to think about my sides. The only thing I have to worry about when I multiply my last terms, 1 times 1 gives me 1. So they can either be both positive or both negative. But my linear term is 3. So my outer terms, 2x times x, plus my inner terms, 1 plus x, has to equal positive 3. So they're both going to be positive. All right, so here I got the max seal of approval. So students look at this and they get so confused. They actually see 4 things going on. They see a 2x, a 1, an x, and a 1. But really there's only 2 things going on. I've got this factor times this factor. And the product is equal to 0. You multiply 2 numbers together, you get 0. At least one of them has to be 0.
That's correct.
So I can set each factor equal to 0. Because either this one equals 0, or this one equals 0. So I'll solve each one. So my x is -1/2 or -1.
There we go.
Okay.
And that's how we solve by factoring.
Yeah, it's a lot easier to factor when your a and c turn out to be prime numbers, because there's only one possibility to factor them.
All right.
Okay. Now, this is actually the exact same problem, except my x's have been replaced with cosine thetas. I'll use the exact same approach. 2 cosine squared theta can only factor to 2 cosine times cosine. If I multiply them together, 2 cosine times cosine gives me 2 cosine squared. Okay. 1 factor gives me 1. And again, the product of my outer terms and my inner terms have to add to give me my linear term. 2 factors multiplied together equals 0. What is going on with this pen? The ink is just running out on this thing. Each one, I've got stuff popping up all over the place. So each factor can be set equal to 0. We solve each one. We subtract 1 from each side. Divide by 2. And come over here, we'll subtract 1 from each side. So I need an angle where cosine is -1/2 and where cosine is -1. Well, cosine is going to be -1/2 at this angle. Oh, you can't even see me. At 4 pi over 3 and at 5 pi over 3. And cosine is -1 here at pi. I messed that all up, didn't I? This angle will be 2 pi over 3. In my third quadrant, I've got 4 pi over 3. And cosine is -1 here at pi. All right. Now, more factoring. I'm still looking over the interval of 0 to 2 pi. 2 sine squared plus 2 sine theta minus 3 equals 0. Sine squared can only factor to sine and sine. Three is prime. It can only go to 3 and 1. The outer product and the inner product adds to give me a positive 2. So the only way I can get a positive 2 is if this 3 is positive and the 1 is negative. And when you're factoring, and if you're not quite sure, if you multiply it back out, you can see if you get the original problem you started with. So again, I set each factor equal to 0. That ink flowing. Subtract 3 from each side. So sine is either -3 or a positive 1.
That ain't gonna work, Mr. Sims.
Why not?
Because
My math
sine-
is right. I subtracted 3 from each side.
You did your math beautifully.
Thank
but
you.
there's no place that sine can be greater than 1 or less than -1.
Is that right?
That's too small.
What if I graph it out?
It goes up to 1 and down to -1.
Oh, that's
There's
right. It's
no
not going to go up
-3.
above 1, is it? Okay.
That's right.
So this one, it's not that the equation itself has no solution. It just means this factor
That's
will
right.
never equal to 0.
That's
So I
right.
can throw that factor out, but sine will be 1
Mhm.
at pi over 2.
And pi over 2.
So I only have one solution for this quadratic.
All that work for one solution.
Yep.
It happens. All right. Would you like me to do one, Mr.
Sure.
Simmons?
Go for it.
All right. So I'm just gonna come over here, and I might change the color just for fun. Let's make it
Why not?
purple. I don't know. All right. So we're gonna factor this, and we have 2 sine squared theta minus 3 sine theta plus 1. So 2 sine theta will only factor into 2 sine theta and 1 sine theta, and 1's only going to factor into 1 and 1. Now you got to be careful. When I multiply 1 times 1 together, it's got to be positive. But when I add the outer and the inner, it's got to be a -3. So that means that both of these have to be signs have to be negative, because negative 1 times negative 1 is a positive 1, and then negative 2 sine theta and negative 1 sine theta is negative 3 sine theta. Alright, the outer and the inner, you know what I mean? Alright, so now, we said each factor equal to 0, and we solve them. So we add 1, and it becomes 2 sine theta equals 1 divided by 2, and sine theta equals a half, and then here we add 1, and sine theta equals 1. So where's sine theta a half? Sine theta is a half, why? At pi over 6.
Yep.
And
5 pi over 6.
So theta equals pi over 6 and 5 pi over 6. But theta, sine theta also equals 1 at pi over 2. So there are my answers. Pi over 6, 5 pi over 6, and pi over 2. Now if you really get happy and you want to do something, you can plug those values in and do some math and see what you get. Guaranteed 0 every time. So now we've got to find all these solutions. Well, we're not going to do this one because it's a double angle and we're not ready for double angle. But we will be. But we can do this one right here. Why don't I do that, Mr. Simmons? You've been just working away. I'll do this, I guess. So, what I like to do here, guys, is I like to try to get everything over on one side, because if we have a quadratic term or a term that's squared and a term that's not squared and a constant, ax squared plus bx plus c, we usually let that equal 0 so that we can solve and find the zeros or the roots or x-intercepts. So, let's move our 1 over, and we have cosine squared theta plus sine theta. It's negative 1 on the right. To move it over, we have to add it. So when we do, we'll go to factor, we got a problem. We got cosine squared and then a regular sine. And all the other problems, it was sine squared and sine, cosine squared and cosine. But we're going to have to rewrite this. But I know a Pythagorean identity for cosine squared.
Oh yeah?
Isn't it 1 minus sine squared, Mr. Simmons?
I thought it was cosine squared plus sine squared equals 1.
Oh my word. No, it's cosine squared equals 1 minus sine squared theta.
Okay.
So, and then sine theta plus 1 equals 0. Let's combine our like terms. There's a positive 1 and there's a positive 1. Sine is negative sine squared theta plus sine theta plus 2 equals 0. Now, I don't know about you guys. You can factor it from here. I prefer to have this quadratic term, if you will, be positive, the one that's squared. So I'm going to multiply this whole equation by negative 1 and change all the signs.
We want a positive outlook.
A positive outlook. There you go.
Well, hang on now.
Uh-oh, I forgot to make that minus. Alright, so I multiplied that by negative, positive, that by negative, turned it negative, negative, and then 0 times negative 1 is just 0. So we're good. Now I'm ready to factor. So I have sine theta, and 2 and 1. I wonder what my signs need to be in those factors. Well, I've got to multiply them together to get a negative 2, so the signs have to be different.
One
negative
positive,
times
one
positive, that's right.
So which one's positive and which one's negative?
Well, when we do the outer and the inner, that's a positive 1 sine theta. This is a positive 2 sine theta without the signs. And I need a negative 1 sine theta in the middle. So I better make this 2 negative and this 1 positive. That way I get a positive 1 sine theta and a negative 2 sine theta.
And when you add them, you get negative.
When I add them, it's negative 1 sine theta. That's right.
Negative 2 plus 1.
That's right. So then I set these equal to 0. Sine theta minus 2 equals 0. And sine theta plus 1 equals 0. Add 2 to both sides. But I don't think there's anywhere that sine can be 2.
No.
And then subtract 1 here. And that'll be sine theta equals negative 1. And the only place that y is negative 1,
3 pi over 2.
3 pi over 2. Now there's a lot of places sine's negative 1. Negative pi over 2, 3 pi over 2.
But those are all coterminals. And if you'll scroll up a little bit, we saw our solutions had to be within the interval 0 to 2 pi.
Exactly. So be careful with these. See how not, first thing we had to do is use Pythagorean identity. and then we had to factor. So we're just adding a little bit to it as we go. All right, so there's a now you try. So again, this would be a good time to pause the video, try these couple of problems, see what you can do. We're going to go ahead and solve these suckers out.
All right.
So, we need to, first thing I see a cosine and I see a sine squared. So you got an option. We can go ahead and get all our terms together on one side of the equation, or we can go ahead and use the Pythagorean identity, because if I've got just a linear term or a cosine of theta, if you will, with no square, then I probably need a cosine squared. So I can turn this into something else using identities. But cosine becomes 1 over secant, and that would be zero help whatsoever. Correct. That would make a mess. We don't want to do that.
No.
So why don't we go ahead and just turn this
Okay.
into a Pythagorean. So we got 3 cosine of theta plus 3 equals 2 times, and what is the Pythagorean?
Well, it's sine squared plus cosine squared equals 1, but if I subtract cosine squared from each side, I'll have sine squared equals 1 minus cosine squared.
So then sine squared theta is 1 minus cosine squared theta. Is that correct?
Yeah, that's correct.
Alright, and then of course we get to distribute out with 2. So that's 2 minus 2 cosine squared theta, and that's 3 cosine theta plus 3. Now let's get everything together. You know, one big happy family, you know.
Alright.
So I'm going to move this over to the left by subtraction, by addition, because it's subtraction over on the right. So that'll be 2 cosine squared theta. The 3 cosine theta was already on the left, so stays just where you want it. And then I'm going to move this 2 over here. Well, it's a positive 2. I know behind it says minus, but we look in the front or to the left. So it's a positive 2. To move it to the left, we subtract. So it'll be 3 minus 2 is 1.
Okay.
And then when we factor, that'll be 2 cosine squared, so it factors into 2 cosine theta, and 1's only going to factor into 1 and 1. And again, sine is positive, so both signs have to be the same, either both positive or both negative. But since I got a positive 3, they're both
It's all positive.
positive. Then we set our factors equal to 0. It's kind of lagging today, isn't it? And then we subtract 1.
Either that or we're trapped in a time vortex.
That is probably more realistic than lagging.
I think so.
Yeah. So we divide by 2. So the cosine of theta equals negative 1/2. And we'll come back and ask ourselves where that occurs in just a minute. Subtract 1. I usually like to go ahead and get my cosine thetas and sine thetas isolated first. So now you can go ahead and say theta equals arc cosine or cosine inverse of negative 1/2 and all. But I usually just stop at this point, and so I ask myself, cosine of what angle is negative 1/2? Well, cosine's x. X is negative in the second and third quadrants.
Correct.
And where's cosine 1/2? That's got to be at the pi over 3 reference angle. So theta equals pi over 3.
Well, that's only the reference angle.
Right. So we got to be in the second quadrant, so that should be 2 pi over 3.
Correct.
And 4
In the third
pi
quadrant.
over 3 in the third quadrant. That's a 2 pi over 3 in case you can't read that. And then cosine is negative 1 at, and of course you can either do it here. I just kind of come here and put the comma at pi. So there are my answers: 2 pi over 3, 4 pi over 3, and pi. Ms. Simmons, would you like to finish that last one?
All right, now look at this. I see all these square terms. I've got cosecant squared and a cotangent squared. They all have coefficients, so I can't do direct something with both of them. I'll have to do something like this. All right, now if you don't actually have these Pythagorean identities memorized, you can quickly derive them. If I've got sine squared plus cosine squared equals 1. You can't read that. If I've got sine squared plus cosine squared is 1, and I want a cotangent or a cosecant, I want to get 1 in terms of the error. I'm thinking it would be easier to get cotangent in terms of cosecant. So at the end, I can flip cosecant and get sine and just think about y. as opposed with a cotan or tangent thinking about both x and y coordinates at the same time.
Works for
It
me.
seems like, to me, that would be a little bit easier. So to get a cosecant, I need to divide everything through by sine squared. I'm sorry, I'm converting cotangent to cosecant. So to get a cotangent, I'm going to divide everything by sine squared, by cosine squared. So I'll have sine squared over, I did it backwards, didn't I?
Yeah, you'll end up with...
That'll give me tangent squared. If I divide everything by cosine, by sine squared,
we'll get it in a minute.
sine divided by sine is 1. Cosine squared divided by sine squared is my cotan.
You'll catch it in a minute.
And 1 divided by sine squared is my cosecant squared.
That's right.
Okay? So, if I subtract 1 from each side, I can replace cotangent with cosecant squared minus 1. So if you don't know these, you can always derive them. Okay? I'll distribute on the right-hand side. All right. Now, you'll notice I don't have any linear cosecants. They're both squared.
They're both squared.
To keep it positive, I'm going to subtract 2 cosecant squared from each side. That'll give me a 1 cosecant squared. A negative 3 and a negative 1 will give me a negative 4. Bring it up to the other side, it will be a positive 4. So to solve, I take the square root of each side, and I need to take the positive negative root. And the square root of 4 is 2. I've got a cosecant. I can turn that cosecant into a sine and reciprocate the opposite side. So I need angles where sine is positive or negative 1/2. And on your unit circle, that's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6.
4 answers.
So I guess I need to write that all down.
Oh, good.
5 pi over 6, what did I say? 7 pi over 6 and 11.
And there are your answers for 2 cosecant squared theta equals 3 cotangent squared theta minus 1. There
And
it
if
is.
you know the first trig function, Pythagorean identity, sine squared plus cosine squared is 1, you can derive all of the others.
And that's what we did to actually do it in the first place.
Yeah.
All right, so the next thing is homework. We don't need to show that. We can give them that in class. So watch the video to make sure that you are understanding how to factor, how to use identities, and then work on your factoring. And then, of course, the solving is the same as we've been doing with the basic stuff. Once you get it to a point like cosine theta equals negative 1/2, then you can use a unit circle to figure out what those answers are. So good luck and work hard.
That's right.
We're out of here.